Hello everyone, my name is Andrea. Halloween is just in 2 weeks' time, and today I thought I would show you how to make your own interactive Halloween pumpkin using Arduino. Let's get started! These are the components you're going to need for the project. So we'll need one Arduino Uno R3, and we're going to need also an Arduino USB cable for debugging, a prototyping breadboard, some jumper wires, a 5 volts 1 meter RGB LED strip, an HC-SR04 ultrasonic sensor, a micro SD card memory shield module and a micro SD card as well, one 8 ohm 1 watt speaker, a 9 volts battery holder and a 9 volts battery, and indeed our Halloween pumpkin. Okay, so the interactive pumpkin will have two main states, a default state and an active state. The default state, the pumpkin will just flash out a red fading light using the RGB LED strip, and we're going to use the proximity sensor to detect whether a person is in front of the pumpkin, and if it is, we'll be changing the state to active, and the pumpkin will flash out random lights using the same RGB LED strip, and at the same time we'll be playing a sound through a speaker, reading the file from a SD card. Okay, let's wire up the circuit first. So we connect the 5 volts of the Arduino to the 5 volts or positive rail of our breadboard. And we connect the ground of Arduino to the negative rail of our breadboard. Next, the speaker. So we connect the positive terminal of our speaker to pin number 9 of Arduino. So the positive to pin number 9, and the negative side of our speaker, negative terminal, to the ground rail. Next, the LED strip. So the LED strip has 4 different terminals, a positive, blue, red, and green terminals. So we place the positive into 5 volts, the red to pin number 3 of Arduino, the red to pin number 3, the green to pin number 5, and finally the blue to pin number 6. So we have the red on pin number 3, the green to pin number 5, and the blue to pin number 6. Okay, next is the proximity sensor. So the proximity sensor has 4 different terminals. So as a VCC, a trig, an echo, and ground as well. So we connect the VCC to 5 volts. So VCC to 5 volts, so the positive rail. Ground to the negative rail. Now we connect the trig terminal to pin number 1 of the Arduino, and the echo to pin number 2. Like so. Okay, so the last thing to wire up is our micro SD reader. So the micro SD reader has the ground, VCC, meso, MOSI, SCK, and CS terminals. So the ground terminal goes to the negative rail of our breadboard. The VCC goes to the 5 volts or the positive rail of our breadboard. Now the meso goes on pin number 12. The MOSI goes on pin number 11. The LED goes on pin number 13. Pin number 13, there you go. And the CS goes on pin number 10. Like so. So now we have all our components wired up. So it's time to program our circuit. So what I'm going to do now, I'm going to open up my Arduino IDE, which you can download it from the main website. It's going to take a few seconds to open up. And it should have already my sketch in it. Yeah, so this is the sketch I programmed already for our circuit. I'm just going to go and explain what everything does in the sketch. It's a pretty simple sketch, so there's not much going on, but I'm just going to go through it anyway. So the first thing I'm doing, I'm defining some variables. So I'm using trig pin and echo pin. These are the attached to pin number 1 and 2 of the Arduino, and these are used for the proximity sensor. The red, green, and blue on pin number 3, 5, and 6 of the Arduino. They correspond to the red, green, and blue components of the RGB strip. The two long variables, duration and distance, they are used for the proximity sensor, and we'll be using them later in the program to calculate the distance of an object from the proximity sensor. The string state, so the string basically, I'm using a string to determine the state of the pumpkin. If you remember, we said we have a default state and an active state as well. I'm using 4 ints to determine the brightness of the red component of the LED strip. Same thing for the green and the blue. And the fade amount is how fast should be the fading effect of the RGB LED strip. I'm then including the sd.h, so basically I'm including the SD library so that we can read a file from the SD card module. I'm attaching an SD card, a variable called SD card, to pin number 10. And I'm just including the tmrpcm.h, which is another library to play audio. And I'm creating an object of that type called sample. So sample is the name of our object. Down here in void setup, the first thing I'm doing, I'm setting the state to passive. I said we had default and active. Passive is the default state. You can change that to default if you want, but I leave it for passive. I leave it to passive for this time. I'm starting a new serial. So it lets you sort of debug things and print things on screen if you need to see what's going on in your code as well. So the trig pin and echo pin. So the trig pin is set to output and the echo pin to input. So we're gonna send a signal through the trig pin, and we're gonna read it from the echo pin. These are related again to the proximity sensor. The pin mode, red, green, and blue, they all output because we want to write. We want to send out a signal to the RGB LED strip. And what I'm doing here, I am setting the value of the red, green, and blue strip to a maximum value. Now, for some reason, on my Arduino Uno board, it seems like it's sort of flipped, which means that in an analog write, you send a PWM signal. So if you put 0, you would see no signal, sort of no light coming through the LED. Whereas if you put 255, which is the maximum number, so it ranges from 0 to 255. If you put 255, you would send a maximum signal, so you would see like the LED in a full light. For some reason on my program, on my Arduino board, is flipped. So I don't know why yet, but think it as if it was 0. So now we're setting all the colors of our RGB strip to 0. So we want no light to come out from our LED strip. We assign the sample.speaker pin to pin number 9. So this is the pin where the positive rail of our speaker is. So we want to send out a signal from pin number 9. And this if statement is just searching for SD cards available. And if there's no available card, it's going to tell you. Otherwise, it's going to keep going. And we just set up the volume for our sound to 7. So you can put number from 0 to 7 over here. 7 is the maximum, 0 is the minimum. So I'm putting it very, very loud. Okay, in void loop, the first thing we do, I'm calling a function called check distance. And what check distance does, it's basically checking and calculating a distance from the proximity sensor to an object. Okay, so the first thing we do, we set the trig pin, which is the signal we want to send, to low. So we don't want to send any signal at the beginning, but for a very limited amount of time, so for 2 microseconds. After that, we send out the signal, and we keep that signal for 10 microseconds before setting it to low again. Okay. Once we send the signal out, we store in duration the pulse in echo pin high. So we store the duration of that, that sort of journey. So from when we send the signal to when it comes back. Okay. And once we have that duration, we can calculate the distance by dividing the duration by 2 and then divide it by 29.9. This is just a maths formula that returns the distance for you. And so once we have that, I'm printing it out on serial. But you don't have to do that. But now in our distance, we have the distance in centimeter from the beginning point of the proximity sensor to the object in front of it. So here, so we check the distance now. So we have a distance value from the proximity sensor, and we can play around with the distance to determine whether our pumpkin is in a default state or in a active state. So I'd say if the distance is less than 30 centimeters, and also is different from 0, which means that we want our pumpkin to be active. What we do, we randomize the brightness of the red, green, and blue components of the RGB LED, and we write that out. So we randomize the light's color, and at the same time, we play a master.wav, which is our file. Instead, if the distance is greater than 15, which means that there's nothing in front of our pumpkin, because the proximity sensor is gonna detect a greater distance than 15, then what we do, we set the green and blue to 0. Now remember, as I said, for some reason mine is flipped, so I put 255, 255, but no green light, no blue light. I'm adding to my red brightness the fade amount that we set at the top. Remember, that was 7. And if my brightness red is greater than 250 or it's less than 5, then fade amount becomes minus fade amount. What this one does, it increments the sort of the brightness of the red brightness of the LED component up to a maximum of 250, and once it reaches that point, it's going to subtract the fade amount up to 5, and once it's less than 5, it's going to go up to 250. So you're going to have that sort of fading effect. And then what we do, we just write it out over here. So this is pretty much the code. As you can see, it's very simple. Now I've just noticed I'm not actually using state. I'm not actually using state over here because I'm just doing everything with an if statement. But you can use a state. So you can say down here, you can say if distance is less than 30 and distance is different than 0, then you set the state to be active. Otherwise, you set the state to be passive, and then you can play with those two strings to either fade in and out the red, or just randomize colors and play the music as well. So this is all the code. There's one more thing I want to mention. As you can see here, down here, let me go where we're playing the sound. So yeah, sample.play monster.wav. This is the name of the file that you have in your SD card. Okay, it must be a WAV and file, and not only that. So let me show you. You need to convert it to a 16,000 kilohertz and 8-bit and a mono sound as well. Now, I'm not very expert in sound, but I'll show you one way of doing this. So if you open up iTunes, if you go to Preferences, and you look into Import Settings, you import using WAV encoder, and you press Custom, and this is the numbers you need to put inside. So you want a 16 kilohertz sample rate, you want an 8-bit sample size, and a mono channel as well. Once you did this, you all set. What you do, you select a file that you want to export. Let's say, I don't know, anything. This one, you go File, Convert, and create what version of it. Okay, that's what you do. And now it doesn't let me do that because it's in the cloud. So let me take another example. Let me take a jump sound. You go File, you go Convert, and you go Create what version. And if you click here, it's going to create that for you. So now what you do, you take this one, you put it into your SD card, and you're all ready to go. Okay, remember this, the name of the file must be the same as the name that you put here, otherwise it won't work. Once you guys did this, you all set, and the next step will be to upload the sketch onto your Arduino board. So what you do, you just connect Arduino through the USB cable to your computer, and you just upload the sketch to the board. And once it's done, you guys have your own interactive pumpkin ready to go. Okay, so now that we have programmed our Arduino, there's a few things left to do. The first one, you need to take the SD card where you have your file, your sound file in it, and you need to put it into the SD card reader, like so. The second thing is that we miss a power supply. So I'm going to use a 9 volts battery with a 9 volts battery case as well. So you place the battery in the case, and you need this adapter to power the Arduino from an external power source. So the battery case is attached to this cable. It's just a plus and minus cables. It's very simple to do. And what you do, you just plug this into the Arduino. Once the Arduino is plugged, the only thing you have left to do is to put everything inside your pumpkin. So you place all the objects inside of the pumpkin. Now you can put some paper inside the pumpkin, as I did, because the pumpkin is quite humid when you curve it, so you want to put some oven foil inside. You place the LED as well. Place all the cables inside of the pumpkin. Place the speaker as well. And the battery holder. Now this is up to you. You can keep it inside, or you can make a hole and just leave it outside, so you can control the pumpkin on and off. But for this time, I'm going to put it inside. So the only thing you want to keep outside is the actual proximity sensor. So you can either stick that inside the nose of your pumpkin, like this, or you can just leave it outside. in front of the pumpkin, and then close the pumpkin like so. Okay guys, now that you put the circuit inside the pumpkin, the only thing left to do is to actually power on the old system. So I'm going to use my 9 volts battery. So you power it on, and you can see that the pumpkin will go to its default state, which is the fading effect. So it's going to fade in and out the red light. You can see actually doing it. It goes off and it comes back on again. I placed the proximity sensor at the back of the pumpkin, but again, you can place it anywhere you like. You can put it in one of the eye, you can put it in the nose, and the mouth as well. So you can see as I move my hand in front of the sensor, the pumpkin will flash out different lights. So it's in a new state, it's the active state. And as soon as I take it off, it's going to play a sound and then it's going to go back to the default state. Now let me turn off the lights so you can see that better. Okay, now it's fading in and out. You see that slowed off and coming back on again. If I place my hand, there you go. Thank you so much for watching. Hope you guys had great fun making this project. I wish you all happy Halloween, and don't forget to subscribe to the channel for more videos like this.